Good day, everyone. My name is Giorgio Meldas, and our topic today is all about the law of sines. So, the law of sines helps you solve for sides or angles in oblique triangle. So, sine A is over A is equal to sine B over B equal to sine C over C. You can also use it upside down. So, A is equal to sine A over B over sine B is equal to C over sine C. So, use law of sines when you have three parts of triangle and you need to find the other three parts. They cannot be just any three dimensions though, or you won't have enough info to solve the law of sines equation. Use the law of sines if you are given A as two angles and one adjacent side, ASA two angles and their included side, or ASS sometimes two side and their adjacent angle. So general law process for law of sines. Number one, except for ASA or two angles and their included side, triangle, you will always have enough information for one full fraction and half of another. Start with that to find a fourth piece of data. Once you know two angles, number two, once you know two angles, you can subtract from 180 to find the third. To avoid rounding error, use given data instead of computed data whenever possible. Example number one, solving this triangle. So this triangle, 80 degree, B is 80 degree, A is 70 degree. Then the hypotenuse is 12. So this angles is in a triangle total 180 degree. So solve for angle C. Set up the law of sines to find side B. So here 12 over sine 70 degree is equal to B sine 80 degree over sine 80 degree. So 12 times sine 80 degree is equal to B times sine 70 degree. So B is equal to sine 12 times sine 80 degree over sine 70 degree. So B is equal to 126 centimeters. So 12 over sine 70 degree is equal to C over sine 30 degree. So 12 times sine 30 degree is equal to C times sine 70 degree. So C is equal to 12 times sine 30 degree over sine 70 degree. So C is equal to 6.4 centimeters. So angle C is equal to 30 degree. Side B is equal to 12.6 and side C is equal to 6.4. So example 2. Solve this triangle. And this you can see the triangle here. You're given both pieces for sine A over A and part of sine B over B. So we start there. Sine 45 is over 30 is equal to sine 50 over B. So we're gonna find the B. So B sine 45 is equal to 30 sine 50. B is equal to 30 sine 50 over sine 45. Then using calculator, B is equal to 32.5. Then the next one is sine A over A is equal to sine C over C. So sine 45 over 30 is equal to sine 85 over C. So say sine 45 is equal to 30 sine 85. So C is equal to 30 sine 85 over sine 45. So using calculator, C is equal to 42.3. Yes. So example 3, solve this triangle. Since we can start one of the fraction, we'll start by finding c. So c is equal to 180 minus 35. As you can see here, we got the 35 here, 35. So minus 10, and then the 10 is equal to 135. So since the angles were exact, this isn't a rounded value. We use sine c over c as our starting fraction. So sine c over c is equal to sine a over a, and sine c is equal to c over c is equal to sine b over b. Since sine 135 is equal is over 45 is equal to sine 35 over a, so sine 135 over 45 is equal to sine 10 over b. So a sine 135 is equal to 45 sine 35. A 45 sine 35 over sine 35 is equal, using your calculator, is a is equal to 36.5, while b sine 135 over 45 sine 10, you will find the b, so b is equal to 45 sine 10 over sine 135. So b is, using your calculator, b is 11.1. So that's our topic for today. Goodbye and thank you.